Hi everyone, Miss Gals here. We'll be looking now at Chapter 2 notes, so make sure you have your notes packet out and something to take notes with. First of all, we'll be talking about analyzing data. There isn't just one type of data. You actually get qualitative and quantitative data. Qualitative data is very descriptive. For example, the color, the taste, smell, or how something feels, that is all qualitative data. So for example, if you were asked to give me qualitative data on a beaker containing a substance, you would say, this substance is green, it feels soapy, it smells like rotten eggs, for example. You would have to be very specific, but it's much more descriptive. It doesn't involve any numbers. Okay. Quantitative data, on the other hand, involves your numbers. A good way to remember it is that quantitative contains an N, and numbers also has an N. Those are measurements such as mass, length, volume. So when you took the length of your gummy bear, the volume and the mass of the gummy bear, those are all quantitative measurements. A measurement must contain a quantity and a unit. Now what that means is that there will be a number and letters each time you make a measurement. These units are very, very important, so it is very important that you don't forget to write your units. There are two systems of units. There's the English system and the international system. The English system involves pounds and ounces and gallons, for example, and it's just very difficult to convert between those. The international system, however, is the one that we use in chemistry, and it's much simpler. Let's page over to the back. Okay. Fundamental units are not always a convenient size, and therefore we use prefixes to change the size of a unit. Now, fundamental units are things like kilogram, meter, second, etc. But referring back to your gummy bear experiment, your gummy bear wasn't close to a kilogram. It was, a couple of grams. So we use prefixes to change the size of a unit, for example, a gram and a kilogram, or a milligram, etc. Okay, a base unit is a unit in a system of measurement that is based on an object for or event in the physical world. Now what that means is that there's actually something, an object, for example, that exists in the real world, and that is how our base unit was derived. So, for example, a kilogram, how did we come up with a kilogram? How much is a kilogram? 1 kilogram is actually defined by a platinum and iridium cylinder that's housed in Paris. So the mass of that platinum iridium cylinder is defined as 1 kilogram. So the kilogram is a base unit. It's actually based on an object found in the real world. Okay, so down here there's a table of your base units, and it is your responsibility to know what these base units are. So for mass, our base unit is the kilogram, and its abbreviation is kg. So if you ever do a measurement and something weighs 1.3 kilograms, the kilogram unit is kg. Length is measured in meters, time in seconds, temperature in Kelvin. Okay. Note that it's not degree Kelvin, like degree Celsius or degree Fahrenheit. It's just K for Kelvin. Volume is measured in the liter, amount of substance in the mole, and we'll talk about that later, electric current in amperes, and luminous intensity in candela. So So make sure you guys know this table. If we look at the next slide, this is slide number 5. Okay. If the unit is, too large or too small to describe a certain object that we measured, we use certain prefixes to make the size more appropriate. For example, if we have to measure a brick, we'll probably want to use kilograms instead of grams. Or if you just want to measure a few granules of salt, you're not going to necessarily want to get its mass in kilograms, rather in milligrams. Okay, so giga, that's the biggest that we're going to work with. Pico is the smallest. You guys are familiar with kilo. That's 1,000 times bigger. Mega is 1,000,000 times bigger. Deci is 1/10 of. Centi, like centimeters, is 100th. Milli is 1,000th. This is 1,000,000th, and this is 1,000,000,000th, and then it gets smaller and smaller. So for deci, deci means 0.1, which is 1/10. Okay, so if we look at meters, okay, if we have 1 meter, a decimeter is 1/10 of a meter. Okay. A centimeter, let's do that down here. A centimeter, centi is 0.01 or 100th. So a centimeter is 100th of a meter. Okay. Now let's look at the other ones. Kilo. Kilo is 1,000 times a meter. Okay. So 1 kilometer is 1,000 meters. Okay. It is very, very important that you guys know what these prefixes are and what they stand for, and also what their symbols are. So kilometers is just K, and it's 1,000 times. It'll make your life so much easier if you know these prefixes. So please make sure that you go home and study these prefixes. This next slide just gives you some more examples, like what I just wrote on the side of the page. For example, 1 kilometer, or km, is 1,000 meters. We know that because kilo is the prefix that means 1,000. A centimeter is 100th of a meter, or 0.01 meters. Centi means 1/100th. Okay. A millimeter is 0.001 meters. Okay. If you look on a ruler, the smallest lines, those are your millimeters. Okay. Weight, 1 kilogram is 1,000 grams. A milligram is 1,000th, okay, or 0.001 of a gram. And you guys note here that this is what I mentioned on Friday when you guys worked with the gummy bears, that 1 cubic centimeter is the exact same thing as 1 milliliter. Make sure you guys remember that. That is super, super, super important. Okay. And these are just some other conversion factors that you don't have to worry about yet at this point. We will get to it tomorrow. Okay. If you look at the back of that, the fundamental unit for length is meter. The definition of a volume is the amount of three-dimensional space occupied by a substance. So how much space something takes up. Since volume is length times width times height. Okay, all three of these are length measurements, and if the fundamental unit for length is in meters, volume is going to be a meter times a meter times a meter, which will give you meters cubed. So the fundamental unit for volume is meters cubed, or cubic meter. And there we go. Volume fundamental unit is cubic meter. Okay. Over here, you guys can see that a cubic centimeter, again, equals a milliliter. And another two values that are exactly the same is a liter and 1 cubic decimeter. Okay. Mass is the amount of matter, or the amount of stuff in an object. Okay. The fundamental unit there is kilograms. Okay. Let's look at temperature conversions. Now, you guys did this with an earlier worksheet, but we're going to be working with these three temperature scales: the Fahrenheit, degrees Celsius, and Kelvin. You guys should definitely remember these values, especially boiling point and freezing point. The boiling point of, and this is of water. Sorry, these two. Boiling point, freezing point of water. Okay. So the boiling point of water in Fahrenheit is 212 degrees Fahrenheit. It's 100 degrees Celsius, and that corresponds to 373 Kelvin. The freezing point of water is 32 degrees Fahrenheit, or 0 degrees Celsius, and that corresponds to 273 Kelvin. Okay. All right. Like I mentioned earlier, there's no degrees before Kelvin, so just it's 273 Kelvin. Okay. This is important. Okay. The last two bullets, it gives you a formula of converting between Celsius and Kelvin. Also, it gives you a formula to convert between Celsius and Fahrenheit. Derived units. Not all quantities can be measured with SI base units. For example, speed is measured in meters per second. A unit that is defined as a combination of base units is called a derived unit. So earlier you guys saw the table of base units. Okay, that was on slide 4. Here it is. Those are the base units. But there are so many units that are a combination of those several base units. Those are called derived units. So the example here is speed. Miles per hour is another example of a base unit. The units for density is another example of a derived unit. We learned on Friday with the Gummy Bear Lab that density, move this up, density equals mass over volume. So the units for density was going to be grams or kilograms if we're dealing with base units over cubic meters. Okay, or in our lab, we actually dealt with grams per cubic centimeters. But either way you write it, the units for density are derived. These are derived units. Okay. All right, and there's a slide that talks about density. Okay, density is the amount of matter present in a given volume of substance. So really, it's mass per volume. A good way to remember, let me put this together. A good way to remember the formula for density is if you draw one of these triangles. D for density goes there, mass over volume. So this will help you remember the formula. Density equals mass over volume. Or if you're looking for mass, you can close this one. If you're looking for mass, mass equals density times volume. Or if you're looking for the volume, volume equals mass over density. Okay. And here are those formulas or the equations that I just showed you using the triangle. Okay. Units will vary. Just like earlier on the previous page, I said density can be kilograms per cubic meter. Whereas with the Gummy Lab, we had units in grams and cubic centimeters. Okay, so the units will vary, but it's always going to be mass over volume. Always mass over volume. Okay. A volume of an irregular solid is determined by submerging it in water, and this is called water displacement. Density. The density of water is 1 gram per cubic centimeter. This you guys need to remember. Okay, the density of water is 1 gram per cubic centimeter. So if you have an object with a density greater than 1, it means it's more dense than water, so it's going to sink. If the density is less than 1, it means it's less dense than water, so it's going to float in water.